So hello everyone. So welcome to this video. So as you know that the fourth sem students have just completed their exams. That is the exam was related to the electromagnetic theory. So in this video, I'm just going to give a brief analyzation of my analyzation and my overview about the question paper. Okay. So how was the question paper from each module? Whether the questions which I had taught in my videos and all the important stuffs which I had provided were the questions there in this question paper, and how was it? Let us see in each in detail. Okay, from each module. So let us start. So before starting this video, my humble request to you guys is please like this video and share this video with all the friends who had just given this exam, electromagnetic theory. And I want each and everyone to comment down about how the exam was for you guys. Okay, what you feel about the question paper? How was your exams? Just comment any at least one word you comment down. Okay, so please comment it because I want to hear your suggestions about how my videos were useful or not. So please comment down. Okay, so let us start now. So the subject was electromagnetic theory, and there are five modules here. Each module would be carrying of 20 marks weightage. Total paper was out of 100. So if you want to pass this subject, you need to be scoring minimum of 35 marks. So let us try to analyze this and let us see whether the students would be able to pass or not. Okay. So let us start now. Module 1. The question is 1A, 1B, 1C, 2A, 2B, 2C. Okay, let us start from 1A. The question was derive an expression for electric field intensity due to the infinite line charge. Okay, so this is not the charge, this is line charge. Okay, so this was one mistake here. Infinite line charge. So this question I had already told you that it would be appearing. So this had already appeared. I have already done it in my concept videos from module 1. Due to the infinite line charge, the electric field and intensity derivation, it is very easy, and the formula also it would be I told you that it would be asked and they have asked it. Okay, so this was one question which I had covered. Define Coulomb's law in vector form in and explain. Okay, that is with the neat figure, the statement of Coulomb's law along with the necessary equations and the each term representation, everything you need to be writing. I have already told you how to write it. So if you write it in that way, you will be easily scoring 5 marks. Okay, and third question is transform the vector field. So here they had told to convert the vector field from one coordinate to another coordinate system. So this is very easy. Here they had given the vector in terms of rectangular coordinate system. They have told us to convert this into cylindrical coordinate system with the points given as 10, minus 8, and 6. 10, minus 8, and 6 are basically the coordinates here. Okay, you see here 10, minus 8, and 6. Okay, so this is again a direct question. The transformation from one system to another, I've already told you how to do it, and this question had come. Okay, so in my analysis, 1A, B, C, if you attempt all these three questions correctly without any mistakes, easily you could be scoring above 15 marks. Okay, from module 1. So this is one another choice question, that is 2A. Here they are told us to define position vector and distance vector with an illustration in Cartesian system. Okay, so this is similar to that of Coulomb's law. Here, if you know the position vector and distance vector. Okay, position vector is for a single uh, coordinate system. Should be drawing one position vector. Okay, it is like a slope line, and the distance vector is between the coordinates. If you join the two line charges, if you don't join the two charges at free space, that line would be calling it as a distance vector. Okay, if you explain this in detail, you could be easily scoring the marks in this as well. Okay, that is 5 marks. Next, 2B. Here they have given a charge of mass. This is not change. Okay, this is charge. Charge of 1 microcoulomb is at point A. What charge must be placed at point B, which will make Y component of total force per unit charge 0 at point C? Assume the media to be at free space. So this question, I agree that this was a bit twisted, and it would be very difficult at one glance to guess it. But if you understand the question very carefully, here they had given to find the charge. Rest all other components are given. Okay, that is force per unit charge is 0. Here they have mentioned also the total force as initially as 0 here. Okay, so that's why if you keep the force as 0, and if you know all other formulas correctly, substitute it, and if without any mistake, if you had done it, there are high chances that you could be scoring marks for this as well. Okay, 2C was a bit difficult, I agree that, but if you observe carefully, it was a bit twisted but not that difficult. Okay, electric charge lies in the plane at z equal to minus 2 meter in the form of a square sheet. Okay, they have given in terms of square sheet. So if you consider a square, you should be thinking one one thing, that is square all the sides are equal. If you know that algorithm correctly, easily you could be scoring marks here, where they had given the x coordinates and y coordinates range, that is -2 to 2. Also they have given the charge density ps of the this value, that is 2 into x square plus y square plus 4 4 to the power 3 by 2. Okay, then determine the electric field intensity. Okay, so this question was a bit difficult, but most of them I guess have not attempted this. So this was about module 1. Now module 2, the first question from module 2 is, that is Gauss law. Related to Gauss law, the first question they have given is, that is electric field intensity. They have given one value, and the charge they have given it as 6 coulomb, is to be moved from point B to point A. Okay, they have given the coordinates as well. Find the work done. Okay, here they have told us to find the work done. So we have a direct formula for work done. Selected path, that is y is equal to 3x square plus z, and z is equal to x plus 4. Okay, they have given two selected paths of traveling from B to A. So this is for path point B, this path, and this is for point A. Okay, point A. So if you understood this question, direct formula is there. Easily you could be scoring marks here as well. Okay. Then 3B, state and prove Gauss law. One direct question. I've already covered it in my video. Okay. So if you had seen that video correctly in detail, if you have written each step, each with the figure, with the each equation step by step, okay, you would be easily scoring this 5 marks. Okay, Gauss law, direct question. Okay, so here also derive the expression for current continuity equation. Again, I've told you continuity equation will be coming for exam. It had come. So this is also one direct question. So here from module 2, these three questions are direct questions. Okay, that is 3A, B, C. You could be easily scoring marks here. Okay. So 4A, obtain E and D for infinite sheet of charge using Gauss law. Okay, E and D are electric field intensity and electric flux density using infinite sheet charge using Gauss law. So this I've already done it in my video. Okay, I've told you because this was not there in the model paper as well. Most of you were telling that this was of not no use, but still I've told you that this is very important, and I have done it in my video. Okay, if you observe the after Gauss law, one concept, small concept I had done, one small derivation type, that was this question only. Okay, 4A. Observe carefully, they have given infinite sheet of charge using Gauss law. So one simple derivation, just thing is here, if you find the value of E, easily you could be finding the value of D. That is, we have an expression for E one term. Okay, then we know the relation between E and D, that is D is equal to epsilon times E. So whatever you got the answer of E, just multiply it with epsilon, you will be getting the answer of D. Okay, so this I've already done it. I've told you it would be coming, and it has come. Next, this is also one direct question. They have given flux density as this value here, phi r square AR vector millicoulomb per meter square for r is equal to, for r less than 0.08, and one more value of flux density, zero point 0.1 r square AR vector millicoulomb per meter square for r greater than zero point 0.1. Find volume charge density for r equal to zero point 0.6 meter and volume charge density for r equal to zero point 0.1 meter. Okay, so they have given two cases, two different cases, and they have assumed the flux density to be in the spherical system. Okay, so this is also there. We have one direct formula here where you should be considering two separate cases and you should be solving it. If you had solved it, you would be easily getting marks here as well. Okay, here this also one direct question here. Current density they have given it as 2 by r cos theta ar. Okay, this is in the spherical coordinate system here, where they had given the values of r, theta, and phi. Total current passing through the sphere is r, with r equal to 3 meter is, for theta they have given the range, and for phi they have given the range in the ar direction. Okay, they have mentioned only for ar direction. So the current equation, you could be with respect to j, one equation is there, that is one continuity equation. If you put the that formula and if you solve this, you would be easily scoring the marks for this as well. Okay, so this is about module 2. Next, module 3, you see here, first question is find E at point P312 for the field of two coaxial conducting cylinders with V equal to 50 volt and R equal to 2 meter, and V equal to 20 volt at R equal to 3 meter using Laplace equation. Okay, so using the Laplace equation, easily you could be finding the electric field intensity, that is E is equal to delta times V. Okay, they have given the for a particular point, use that formula. They have given two separate conditions, solve for two separate conditions and get the answer. Okay, it's very easy. Okay, direct formula. Here 5B as well, calculate the value of J, that is current density, if they have given the value of H as 1 by sine into a theta at P is equal to 230 degree 20 degree. Again, this is in the spherical coordinate system. You know the relationship between J and H, right? Very easy. That is J is equal to mu times h. Okay, use that formula and get the answer. Very easy. This is a direct question. Okay, for five you could be easily scoring 5 marks. This also deduce Poisson's and Laplace equation using Gauss law in point form. Write the Laplacian operation for v for different coordinate system. Okay, so this is for module 3 first video. Okay, in the first video of module 3 we had derived the equation for E is equal to delta times v. Okay, so that if you write that equation, Poisson's and Laplace equation together, along with that, we have listed the Laplace equation on V in different coordinate systems as well. That is rectangular, cylindrical, and spherical. Okay, direct question they are mentioned. So if you observe these three questions from module 3, they are direct questions. Okay, easily you could be scoring marks here. Next, 6a, derive the expression for magnetic field due to infinite long straight line using Biot-Savart's law. So this also I've covered it. Okay, in my conceptual videos, this concept I've already covered it. 6b. So this problem was a bit difficult. Okay, this was I know that most of the people have failed to solve this problem because this was a bit difficult. They have given a coaxial cable with radius of inner conductor A, inner radius of outer conductor B, and its outer radius C. Outer conductor carries plus I and inner conductor carries minus I. Okay, so this was basically a problem of concentric circle. If you know the concentric circle concept in a detailed way, you could be easily solving this problem. Okay, so this one simple condition I already told you in the module 1 of flux density. Under that I've told you the concept of concentric circle, so that they have given it here in module 3. Okay, they have given four different conditions where you should be drawing four circles. Okay, that is for r less than a, r between a and b, r between b and c, and r greater than c. Okay, so this was a bit difficult. Next, from module 4, 7a, in a certain region, the magnetic flux density in a magnetic material with xm equal to 6 is given by this value for magnetic flux density. At y equal to 0.4, you should be finding j, jb, and jt. Okay, so this problem was a bit difficult. Okay, because they had told you to find the three different current density components using magnetic flux density. Okay, that was a bit difficult. Okay, next, derive Lorentz force equation and explain. Okay, Lorentz force equation, again it's a direct question. Next, derive an equation for force between two differential current elements. So this I have already covered it, and I told you that this would be appearing. So this has appeared. So 8a. Oh, so this was it's a direct question, not nothing much to do. The solution is very easy. They have given a square loop of wire. Okay, so this is that square loop of wire in z equal to 0 plane carrying 2 milliamp in the field of an infinite filament. Okay, this is an infinite filament. Okay, where it doesn't has any end, and on it is on the y-axis, and we should be finding the total force on the loop. Okay, the force extracted on the loop with respect to the y coordinates, you should be finding it. Okay, where they have given the current sheet current as 2 milliamps, and with the coordinates which they are mentioned here. Okay, using that, if you understand the algorithm, if you understand the problem correctly, easily you could be answering this question. But for most of the students, I know that this would be very difficult. Okay, so next, this is very easy, related to boundary conditions with respect to magnetic field intensity and flux density. They have asked for the tangential component, to obtain the tangential component having the permeabilities mu1 and mu2. Okay, so this was about the magnetic boundary conditions. One problem I've already told you in my conceptual videos. So those, if you had followed that correctly, easily you could be answering this as well. Okay, then comparison between electric and magnetic circuits. So this is also very easy, nothing much to do. Electric field intensity and magnetic field intensity, what is the difference? If you write even the expression, that is if you write d is equal to epsilon times e and j is equal to mu times h as one difference, like that, some 4 to 5 key differences, if you write it, easily you could be scoring 5 marks for this as well. Okay, very easy. Module 5, first question 9a, explain the inconsistency of current continuity. Okay, inconsistency in Ampere's law with respect to the continuity equation. I have already covered it in my video. Okay, so if you had watched that video very carefully, you could be easily scoring this. Okay, 7 marks. Next, derive general wave equation of E and H for the media with parameters mu, epsilon, and sigma. So this I've already covered it. That is uniform plane wave. In that uniform plane wave concept, in that in the model paper also it was there. That is show that uniform plane wave is traverse in nature. Okay, for a good conductor, that one full derivation I've done it. In that I've told you to derive with respect to E and H. So if you had written that in the correct manner, easily you could be scoring 8 marks as well. Then this is one problem here. A circular loop conductor lies in z equal to 0 plane and has a radius of 0.1 meter and resistance of 5 ohm. Given the value of flux density as zero point 0.2 sine 10 to the power 3t Tesla, determine the current in the loop. Okay, so using the relation of current and magnetic flux density with respect to the z plane and the radius, you could be easily for doing this problem as well. So next is 10a. Derive Maxwell's equation in integral and point form for static, electric, and magnetic fields using Faraday's law, Ampere's circuital law, and Coulomb's law. So this question I've told you right, it would be appearing. See, I've multiple times I've stretched that this is very important, and I've already covered it. That is for separate for static and for different electric and magnetic fields in both point form as well as integral form. The set of equations I've told you for Faraday's law, Ampere's law, and Coulomb's law, Coulomb's force of attraction, different set of Maxwell's equations. I've already done that video separately. Okay, so those who have seen that video, it would be very easy for them to answer this question and it could be easily getting 8 marks. Okay, and one problem again. This is the same problem which I have done. That is one important problem related to module 5. This type of problem where here they have changed the values, but they have told us to find the attenuation constant, phase constant, wavelength, velocity of propagation, intrinsic impedance, propagation constants with the given values of mu r and epsilon r. Okay, so this also I've covered it. So only the values have changed. One kind of problem I've done it. If you had solved this easily, you could be getting 6 marks here as well. And this is also a direct question. I've told you it would be appearing. That is, state and explain pointing theorem. Okay, so this was a direct video, direct question. I've made one separate video for this as well. So those who have watched it, it would be easy for them. They would be scoring the marks. Okay. So if I compare this paper and I would be coming with one conclusion that according to me, from my perspective, this paper was not that tough. Okay, you would be easily passing this paper if you had seen my videos thoroughly. Each and every concept I've already done it. And if you observe, you see here from module one, these three are direct questions. One A, B, C, easy to solve directly. If you write it easily, you could be scoring full 20 marks. Okay, not even 20, just consider above 15. Okay, and here also module 2 also, these three questions 3 A, B, C are direct questions. Okay, easy to solve. State and prove Gauss law. You see here, this is a direct question. Continuity equation also direct question. If you write only these two questions from module 2, you will be getting 11 marks. Okay, and module 4 3 as well. Here, Poisson's and Laplace equation was a direct question. Then this is also very simple and direct question. If you know the relation J is equal to mu times H in spherical coordinate system, if you write this, you would be easily getting marks here. Okay, so passing this subject is not a big issue. Okay, and module 4 also, Lorentz force and force between two differential current elements. These things I've already covered it, and tangential current, that is a magnetic component, that is a magnetic boundary condition. If you solve it for a flux density and field intensity under magnetic field, this also if you write it, you will be getting marks. Comparison between electric and magnetic circuits, you will be easily scoring marks here as well. Inconsistency, I've covered it. Wave equation, uniform plane wave propagation, under that I've done the separate video. And Maxwell's equation, I've covered it. Pointing theorem, and this problem where the values have changed, I've already covered these things. Okay, so I would be coming with this with one conclusion that the paper was not that tough. Okay, it was moderate because I think that the problems were tough. Okay, but the other thing compared to the derivations and the theory part, everything were direct questions. Okay, so you would be easily answering that. If you had watched my video, it would be well and good for you. You would be easily passing it. Okay, if you had watched my video with utmost sincerity, I would be telling you guys there would be no chance that you would be getting failed. You would be easily passing this subject. Okay, I'm not telling only for my videos. If you study with utter concentration, not only my videos, if you watch even other videos also, I would be not comparing mine with other. Okay, I won't be telling that I am superior. If you watch any other videos also, these things are multiple times repeated, and these things have come in the exam as well. Okay, if you see here, so very beneficial for those who have taken the membership. Okay, so I have already told you that I'm keeping the membership, and it had been very beneficial for them because most of the concepts from module 2, 3, 4, 5, which are multiple times repeated, I've already covered there. And those things have taken the advantage. They have taken the membership, and they have taken the advantage, and they would be passing with flying colors. Okay, so thanks for those who have taken the membership, and we would be promising you that we would be providing the best content in the upcoming future as well. So again, from this exam also, I would be telling you guys, those who have not taken the membership, please take the membership. Okay, 29 rupees is not a big amount, and you will be affording that if this type of questions are repeated, and if we have covered it in a correct manner. Okay, so it would be beneficial for you only. So again, I request you guys to take the membership and make a best use of it by watching our videos correctly. Okay, so that you will be easily answering the paper. Also, the upcoming subjects related to control system also in the same way we have done the videos. So please consider to take the membership. And before taking the membership, if you want to make a review of our content, we have kept the module 1 free for control system. Complete all the videos from module 1 are free. Just to see the explanation, and if you like it, then take the membership and access all other modules. Same goes with model paper. So under membership, you would be getting detailed videos from module 1 to 5, then model paper solutions, notes, passing packages, final revision concepts with detailed PDF notes. Everything would be available in the video's description. Go and access it. Okay, just take the membership, guys. Those who have not taken it. So those who have taken it, well and good, continue with the studies and do good in these exams. Okay, so all the best, guys. Do well in the upcoming exams. Upcoming exam is PCS, that is Principles of Communication System. So we have a 10-day gap here. So if you have this 10-day gap, don't waste the time. Try to study not the next exam, but the upcoming exam, that is the control system. Okay, that is a very problematic subject, and more practice is required for that. Okay, so I would request you guys to please study that subject, see our videos, take the membership, and do well in the exams. Okay, so that's all, guys. Thank you.